So, we are the group 3, and today we will explore one of the fundamental gas law, which is Gay-Lussac'S law. We will explain the concept and show the formula and perform a simple but fascinating experiment to demonstrate it in action.
Gay-Lussac'S law states that at constant volume, the pressure of a gas is directly proportional to its absolute temperature, which is in Kelvin.
This means when the temperature of the gas increases, the pressure also increases. Likewise, if the temperature decreases, the pressure decreases, as long as the volume remains the same.
Here are the initial and final pressure, and are the initial and final temperature in Kelvin.
Now, let's see this law in action.
A candle and water experiment. For this experiment, we will need the following materials: 1 shallow plate, 1 glass of colored water, a glass or transparent container, a candle, and a match. Let's now proceed to the procedure. First, pour water with food coloring into the shallow plate, just enough to cover the bottom with a thin layer. Next, place the candle in the center of the plate and light it using a lighter or match. Carefully cover the lit candle with a glass container. Watch closely as the flame eventually goes out and observe what happens to the water inside the glass.
As you can see, after the flame goes out, the water level inside the glass rises. But why does this happen?
When the flame hits the air inside the glass, it increases the air temperature, which increases the pressure. But once the flame goes out, the air rapidly cools, causing the pressure inside to drop. The higher external pressure pushes the water into the glass to fill the lower pressure area. The experiment shows that as temperature increases, the pressure inside the glass also increases, and when the temperature drops after the flame goes out, the pressure decreases. This directly supports Gay-Lussac'S law. Temperature and pressure are directly proportional at constant volume. Gay-Lussac'S law applies to many real-life situations. Some examples include: pressure cookers throw up steam inside. As the temperature rises, so does the pressure. This cooks food faster than regular boiling. On hot days, you might notice your tire pressure increases. That's because the air inside heats up. And since the volume of the tire stays the same, the pressure increases, just like the law predicts. When a bullet is fired, the gunpowder ignites, rapidly increasing the temperature inside the cartridge. This sudden temperature rise causes a significant increase in pressure, propelling the bullet forward at high speed. This is direct application of Gay-Lussac'S law, where increased temperature leads to increased pressure in a confined space. And that brings us to the end of our experiment and explanation of Gay-Lussac'S law. Today, we learned that when the temperature of a gas increases, its pressure also increases, and when the temperature decreases, the pressure drops as long as the volume stays constant. From car tires to cooking and even in engines and firearms, this law plays a big role in everyday life. Science doesn't have to be complicated. It can be seen in simple things, like a candle and a glass of water. Thanks for watching! Remember, stay curious and stay scientific!